Okay, so now we are in chapter 4.4, which is exponential and log equations. Here are our objectives. So let's begin. So first we want to talk about solving exponential equations by expressing each side as a power of the same base. So it says if b to the m power is equal to b to the nth power, then m equals n. So basically they're telling you if you have the same base, so this right here is a basic algebra concept. B represents the base, m and n are the exponents. So if you have the same base, that means that your exponents are equal. So the first thing you want to do is rewrite the equation in the form b raised to the m power equals b raised to the nth power. Basically, you want to rewrite it so you have the same base. Then you want to set m equal to n and solve for your variable. All right, let's go in our books to page 489, and we're going to start by looking at number 13. And it says, solve each exponential equation in exercises 1 through 22 by expressing each side as a power of the same base, and then then setting your exponents equal to each other and solving for the variable. So we have 3 raised to the 1 minus x power, which is equal to 1 over 27. Okay, so first thing first, what's the base on the left side? Well, it's 3. What's the base on the right side? Well, it's 1 over 27. I need these to be the same. So the first thing I need to do is move the 27 from the denominator to the numerator. In order to have the same base, everybody has to be in the numerator. So this will become 3 to the 1 minus x power equals 27 raised to the negative 1 power. Remember, when you move the base from the denominator to the numerator, you are changing the sign of the exponent. Down here it was a positive 1, up here it's going to be a negative 1. Okay, so now I have everybody in the numerator. The next step is to have them be equal bases. Well, this is a 3, so I can't really change him, but can't I write 27 so it's 3 raised to some power? What about 3 raised to the third power? 3 raised to the third power is the same as saying 27. And then don't forget you have the negative 1 on the outside. And then recall that when we have power to power, you must multiply. So you have 3 to the 1 minus x power equals 3 to the negative 3 power. Okay, so our bases, 3 and 3, they are equal. So now we can set our exponents equal to each other. So 1 minus x equals negative 3. And then we're going to solve for x. So how about we subtract 1 on both sides? And we get negative x equals negative 4. And then divide by negative 1. And you have x equals 4. And of course you can plug it back in and check it, and you'll see that it works. Alright, let's look at number 15. So this time we have 6 raised to the x minus 3, all divided by 4, is equal to the square root of 6. Okay, so the first thing we need to do is take care of this square root. I cannot have a square root. I want it to be an exponent. So do you recall how to write the square root as an exponent? Well, it's going to be 6 to the half power. Let me remind you that if you have the nth root of a to the nth power, is going to be the same as a over m divided by n. This is a square root, so the number on the bottom is a 2. And what's the power on 6? The positive 1. So this becomes 6 to the half. Now my bases are already equal, so I can go ahead and set the exponents equal to each other. So x minus 3 divided by 4 equals a half. Multiply both sides by 4, and you have x minus 3 equals 2. And then add 3 on both sides, and you have x equals 5. And of course, you can plug this back in and check, and you'll see that it works. All right, number 21. So now we have e raised to the x plus 1 equals 1 over e. Now you want to treat e like any other base. So right now the base on the left side is e, and on the right side my e is in the denominator, which means I need to move it from the denominator to the numerator. So the left side stays the same. I still have e raised to the x plus 1 power. But on the right, now it's e raised to the negative 1 power. Same rule applies. If you move the base from the denominator to the numerator, you change the sign of their power. Now on the left side we have a base of e. On the right side we have a base of e. They are equal, so now we can set their exponents equal to each other. X plus 1 equals negative 1. Subtract 1 on both sides, and you get x equals negative 2. And of course you can plug it back in and check, and you'll see that it works. Alright, let's keep going. So now we want to use logs to solve exponential equations. So the first thing you want to do is isolate the exponential expression. Then you can take the common log or the natural log on both sides of the equation. I always seem to take the natural log because you can only use the common log if it's a base of 10, whereas the natural log you can do for all bases. So you can take the natural log on both sides of the equation, and then you want to simplify using one of the following properties that we learned before, and then your final step is to solve for your variable. Alright, page 490, let's look at number 33. And it says, solve each exponential equation. I'll let you read the rest of the instructions. 33 says e raised to the 1 minus 5x is equal to 793. Okay, so unlike before, the 3 problems we did before, we were able to make the left side and the right side have equal bases. However, here on the left side, we have a base of e, and on the right side, we have a base of 793. There's no way that we can make these equal, therefore we use this alternate way of solving exponential equations, which is we just use natural log. So I'm going to take the natural log of both sides. So natural log of e raised to the 1 minus 5x power is equal to the natural log of 793. Now remember, or recall, that the natural log and e, they're inverses, so they cancel each other out, and you're left with just the exponent, and your exponent is 1 minus 5x equals the natural log of 793. I'm going to leave this as the natural log of 793 till the very end. So now you need to solve for x, so I'm going to subtract 1 on both sides, and I get negative 5x equals the natural log of 793 minus 1. And then divide by negative 5. Divide all of this by negative 5. So you have x equals the natural log of 793 minus 1, all divided by negative 5. Now I'm going to type into my calculator. If you want to type this all at once, put a parentheses, then type the numerator, close your parentheses, then divide by negative 5. So the natural log of 793 minus 1 divided by negative 5. And we get approximately negative 1.14. We're going to round to 2 decimal places. So negative 1.14. Okay, and then of course you can plug it back in and check, and you'll see that it works. I'm going to go plug it back in and let's make sure it works. One second. And we get 793, so it works. Alright, let's look at number 41. So now we have 5 raised to the 2x plus 3 equals 3 raised to the x minus 1. Okay, so first of all, we have a base of 5 and a base of 3. These will never be equal, so we need to take the natural log on both sides. So I'm going to take the natural log on both sides, and we get the natural log of 5 raised to the 2x plus 3 equals the natural log of 3 raised to the x minus 1. Now, however, unlike before, the natural log and e cancel each other out. Well, the natural log of 5 isn't going to go anywhere, and the natural log of 3 isn't going anywhere. So instead, remember the rule that the exponent becomes the coefficient. So we're going to go ahead and do that. So now we have 2x plus 3 times the natural log of 5 equals x minus 1 times the natural log of 3. Notice that we're solving for x, but x is inside parentheses, which means we need to distribute. So I'm going to go ahead and distribute the natural log of 5 on the left side and the natural log of 3 on the left, sorry. I got them backwards, but you see it on the screen. So now I have 2x times the natural log of 5 plus 3 times the natural log of 5 equals x times the natural log of 3 minus the natural log of 3. Okay, so x is out of the parentheses, but now we need x on the same side. So I'm going to minus x natural log of 3. I'm going to move this guy, this entire thing, to the left side. And how do you do that? You just subtract. So now I have 2x, the natural log of 5, minus x, the natural log of 3, plus 3, the natural log of 5, equals negative natural log of 3. Okay, almost there. This guy does not have an x, so I'm going to move him from the left side to the right side, and of course, let's go ahead and subtract. So now we have 2x times the natural log of 5 minus x times the natural log of 3 equals negative natural log of 3 minus 3 natural log of 5. Notice I cannot combine any of these because they don't actually have the same natural log. They're different. Okay, so on the left side, we see we have an x and we have an x. So let's go ahead and take the x out. So we have x times 2 natural log of 5 minus the natural log of 3 equals negative natural log of 3 minus 3 natural log of 5. And then the last step would be divide by this. So you want to get x by itself, so divide by all of this, and you end up with x equals negative natural log of 3 minus 3 natural log of 5, all divided by 2 natural log of 5 minus the natural log of 3. And when you type this into your calculator, be very careful. I would type the top separately, then the bottom separately, and then divide them. So let's see what we get. So we have negative natural log of 3 minus 3 natural log of 5. And then for the bottom, we have 2 natural log of 5 minus the natural log of 3. You can go ahead and divide those two answers. And I end up with approximately negative 2.80. And of course, you can check this by plugging it back in for the x's in the original problem. So I'm going to go ahead and check it. So that'll be 2 times my answer plus 3. And then 3 minus 1. And they come up to be the same answer, so we know it's right. This problem is involved. It takes a lot of steps. But from the beginning, you'll see that x is inside the parentheses. In order to get it out, you need to get rid of the parentheses, which means you have to distribute. Then you need to get everything with an x on the same side and everything without an x on the other side. And then go ahead and factor the x out and continue solving. Alright, so now let's talk about using the definition of logs to solve log equations. So the first thing you want to do, step 1, is express the equation in the form log base b of m equals c. Then you want to use the definition. Remember, it was base raised to the value equals the argument. So base raised to the value equals the argument, or b to the c power equals m. Then you go ahead and solve for the variable. Now this time when you get an answer, you have to check it in the original equation, because remember, the argument has to be greater than 0, and not all solutions will work. Alright, page 490, let's look at number 73. And it wants us to solve the log equation. So we have 2 times the log base 3 of x plus 4 equals the log base 3 of 9 plus 2. Okay, so we're going to be using quite a bit of our properties that we learned, because our goal is to get it in the form log base b of m equals c, okay, where c is a number. Well, right now we have a log on the left side and a log on the right side. We must get them together. So let's start by subtracting log base 3 of 9 on both sides. Or actually, you know what? Let's do something else. Let's rewrite log base 3 of 9. And go ahead and make the coefficient, this coefficient 2, let's make it the exponent. So now we have log base 3 of x plus 4 squared equals log base 3 of 3 squared plus 2. Okay, well remember, when the base and the argument are equal, these go away, including the log, and we're left with just the exponent. So now we have log base 3 of x plus 4 whole thing squared equals 4. 2 plus 2 is 4. Now we have it in the correct form. So let's go ahead and do our rule, which was rewrite it. So now we're going to have base raised to the value equals the argument. So 3 raised to the 4th power equals x plus 4 whole thing squared. So that's 81 equals, now you gotta go ahead and multiply this out. And remember, when it says squared, it's the same as saying x plus 4 times x plus 4. So you should get x squared plus 8x plus 16. Now this is quadratic, so we need everything on the same side. So we have x squared plus 8x. I'm subtracting 81 on both sides. And you get minus 65 equals 0. So now we want to solve this. And remember, recall, you can solve it using the quadratic formula, or you can factor it. This factors into being x plus 13 times x minus 5 equals 0. Has a product of negative 65, and the sum is positive 8. So then we have x plus 13 equals 0. We also have x minus 5 equals 0. So we get an answer of x equals negative 13 as well as positive 5. But we always have to check it back into our original. With your exponentials, you didn't have to, because it'll always work. But with your logs, that's not always true. So this will, in our original equation, we had 2 times log base 3. Everywhere we see an x, let's put negative 13 plus 4 equals log base 3 of 9 plus 2. Now this check is really this piece right here. You just want to make sure that your argument will always be positive. Well, this is going to come out to be negative 9. And you cannot have an argument that's negative 9. So x equals negative 13 is not a solution. Let's do the same thing with 5. Okay, so 5 plus 4 is 9, and I can have a positive inside my argument. Therefore, I'm going to assume that this is the correct solution. So x equals 5 is our answer. And of course, you can check it, but be careful because your calculator doesn't work in log base 3. You'll have to do some extra stuff to check it. But your main check is just to make sure that your argument is positive. Okay, so now let's use the one-to-one property of logs to solve log equations. So the previous problem, let me go back. The previous problem had a log on the left side and a log on the right side. But in reality, you can simplify that and you just had a number. You had a single log with a number on the right side. What if you have a log on the left side and a log on the right side? So the first thing you want to do is express it in the form log base b of m equals log base b of n. And make sure that you have coefficients equal to 1 in front of your logs. And then you want to use the following property. If you have the log base b of m is equal to log base b of n, and they are the same base, then basically these go away, and you're telling us that your arguments are now equal. M equals n. Recall with your exponentials, if you have the same base, your exponents are equal. Well, here we're saying if you have the same base, your arguments are equal. Then you solve for the variable and make sure you check your answers. Not all of them will be true. All right, page 490, let's look at 81. So now we're still solving log equations, and we have 2 times the log of x equals the log of 25. Okay, so before we can use our property, we need to make sure that this 2 is no longer there. So the coefficient 2 becomes the exponent. And you end up with log of x squared equals the log of 25. Now this is base 10 and this is base 10. They are equal, so the logs go away, and instead the arguments are equal to each other. So x squared equals 25. So now we get to solve for x. So how do you get rid of a square? You take the square root on both sides. And you end up with x equals plus or minus 5. Remember, the square root gives you a positive and a negative. So now let us do our check. And all we're going to do is make sure the argument is always positive. So this is 2 times the log of 5 equals the log of 25. Well, the argument is positive, so it works. And let's check the second one. 2 times the log of negative 5 equals the log of 25. Well, the argument is negative, so that won't work. So the only answer here is x equals positive 5. All right, now 89. Still solving log equations, and it says the natural log of x minus 4 plus the natural log of x plus 1 equals the natural log of x minus 8. Now, in order to use the property, we need a single log on the left side and a single log on the right side. However, on the left side, we have 2 logs. So, it's natural log of x minus 4 plus a natural log of x plus 1. Go ahead and combine your logs into a single log. So this will become the natural log, and because we're adding, we're going to multiply the arguments together. The natural log of x minus 4 times x plus 1 equals the natural log of x minus 8. Now we have natural logs on both sides, which means they're the same base. The natural logs go away, and we have x minus 4 times x plus 1 equals x minus 8. So let's solve it, which means we're going to have to multiply out the left side. So that's x squared minus 3x minus 4 equals x minus 8. It's still quadratic, so we need everything on the same side. So subtract x on both sides, add 8 on both sides, and you'll get x squared minus 4x plus 4 equals 0. Now we still need to solve for x. Remember, you can use the quadratic equation or you can factor. I'm going to factor because this is x minus 2 times x minus 2 equals 0. It has a product of 4, so negative 2 times negative 2 is positive 4, and the sum of negative 4. So we have x minus 2 equals 0 for both, which means add 2 on both sides, and you get x equals 2. Now let's do a check. Let's make sure that really works. So here's our check. We're going to plug the 2 back in for every x to make sure all of the arguments are positive. So we have the natural log of, well, 2 minus 4 is negative 2, plus the natural log of 3 equals the natural log of negative 6. We have a negative argument here as well as here. Therefore, this cannot be a solution. And there is no solution. So the answer would be no solution, or you can write it as the empty set. Okay, so this concludes our video for 4.4. Please email me if you have any questions.